Hello everybody, welcome to Maths Gurpreet. Hope you all are doing fine. In today's lesson, we'll see the proof of midpoint theorem of chapter number 8 Quadrilaterals of grade 9. So the statement of the theorem is saying that the line segment joining the midpoints of the two sides of a triangle. So this is a given triangle ABC. The line segment joining the midpoints of the two sides. These are the two sides of a triangle and these are midpoints. E and F are midpoints of AB and AC. So the line segment joining these midpoints is what? EF. Here we have to show that this line segment is parallel to the third side. This is parallel to BC. So this is the construction we have done. Let's see what we have to prove and what is the construction here. So in this triangle ABC, what we are having? We are having AE is equals to BE and AF is equals to CF. Why? Because these are the given midpoints of these two sides. So AE is equals to BE, AF is equals to CF we have. What we have to show? We have to show that EF is parallel to BC. EF is parallel to BC, and further we have to show that this EF is equals to half of BC, or this EF is equals to half of ED. This thing we have to show. So for this triangle, to prove the result, we will do a construction. What is the construction here? We will draw this CD such that it is parallel to AB. So CD is parallel to AB. Draw, we will write it like draw CD parallel to AB and extend this EF such that it will meet this line at point D. So extended EF is meeting CD at D. This is a construction here. So let's see how to prove that EF is parallel to BC. So to show that EF is parallel to BC, let me tell you verbally what we will do. We will just show that this is forming a parallelogram EDCB. First we will show this is forming a parallelogram, then obviously we will have ED is parallel to BC. When ED is parallel to BC, then we can write EF is parallel to BC. Let's see how we will show this is forming a parallelogram. For that we will take these two triangles AEF and CDF. These two triangles we will take to show them congruent. So I am taking AEF and second triangle is what? CF here and D here. CDF. These two triangles I have to prove congruent. So I'll write in triangle AEF and triangle CDF. What we are having? We are having this angle, these two angles equal. How? By vertically opposite angle. So these two angles will be equal. So I'll write angle AFE will be equals to CFD. How? This is an angle. How? Vertically opposite angle. Vertically opposite angles. Fine. So these two angles are equal. Next are what? AF is equals to CF we have. This is given to us. So AF is equals to CF. AF is equals to CF. This is given. What else? As AB is parallel to CD through construction, then AC is acting as a transversal, then this is making a Z. Then we have this angle will be equals to this angle. Which angle? Angle EAF. EAF. This angle will be equals to DCF. DCF. Fine. So angle EAF will be equals to CDF. How? This is an angle again. This is a side. This is coming from alternate pair of angles. Alternate pair of angles. Why? Because AB is parallel to CD through construction. So by ASA, by angle side angle criteria, we can write that we have these two triangles congruent. Triangle AEF is congruent to triangle CFD. When these two triangles are congruent, now I have what I have? AE is equals to CD by CPCT. AE is equals to CD. I can write AE is equals to CD by CP CT. Fine. So when these two sides are equal and this side is equals to BE, from here this side is equals to this side, this same side is equals to this side, then BE will be equals to CD. So I can mark it as number 1 and this as number 2. From 1 and 2 I can write from 1 and 2 what I am having. AE is equals to BE, AE is equals to CD, so I can write BE is equals to CD. Fine. When BE is equals to CD, when BE is equals to CD, as well as what we have, also what we have, BE parallel to, also we have BE parallel to CD. So a quadrilateral is a parallelogram when a pair of opposite sides is equal as well as parallel. We have proved here that this pair of opposite sides is equal as well as parallel. Therefore, BCDE is forming a parallelogram. So when this is forming a parallelogram, then we have BC parallel to this ED. That is, we can also write BC is parallel to EF. Fine. Or EF parallel to BC. This was the first thing that we have to prove and it is proved here. So it's proved, hence proved. So this is a very important theorem of this chapter, quadrilaterals. Let me repeat what we have done. We were given with triangle ABC with E and F as the midpoints of AB and AC. Through construction, we have drawn this line CD parallel to AB and extended this EF to point D. Fine. After that, we have taken these two triangles and proved them congruent by angle side angle criteria. After that, we have proved by CPCT that AE is equals to CD. AE is further is equals to BE. Therefore, we can write BE is equals to CD. We also have BE is parallel to CD through construction. Now we have a result which is not given in the recent books. Let me show you what is the result. I have given the proof of this result in the last videos as well. You can check my last videos. The result was a quadrilateral is a parallelogram if a pair of opposite sides is equal as well as parallel. So if single pair of any of the sides of a quadrilateral is equal as well as parallel, we have to do nothing with the second pair, then it will directly form a parallelogram. But this theorem is not in the recent books, but I am making use of this result here. Fine. I have proved BE is equals to CD, B is parallel to CD, therefore through result this is forming a parallelogram directly. So when this is forming a parallelogram, then BC will be parallel to ED, or we can write BC is parallel to EF. Why? Because opposite sides of a parallelogram are always parallel. This was the proof for this much part. Let's prove this thing. So this was the triangle ABC. ABC. This is E, this is F. Fine. This extended EF is meeting this line at point D. This was the diagram. These two triangles we have proved congruent. Now, when this is forming a parallelogram, we will write now BCDE is a parallelogram. Therefore, opposite pair of sides is equal. So when opposite pair of sides is equal, I can write BC is equals to ED. So when BC is equals to ED, this ED can be written as EF plus DF. Fine. We have proved these two triangles congruent, AEF and CDF. These two triangles were congruent. So EF is equals to DF. So EF is as it is, this DF can be written as EF. You can write as triangle AEF is congruent to triangle CDF. by CPCT, we can write this result. So BC is equals to 2 times EF. We have to prove EF is equals to half of BC. So I can take this 2 down, half of BC. Other way, one more step, I can write 2EF is equals to BC. Now I'll take this 2 down. I'm having this result. EF is equals to half of BC. Proved. I also have to prove that EF is equals to half of ED. I have proved EF is equals to half of BC. To prove EF is equals to half of ED, what I will do, I will make use of this thing again. BC is equals to ED. Just replace this BC with ED in this proof. So I will write it number 4. From number 3 and number 4, I can directly write EF is equals to half of ED. Or in bracket you can write because BC is equals to ED. Therefore, by combining these two results, this is number 5. We can write that EF is equals to half of ED is equals to half of BC. So this was all for today. We will see the proof of the converse of the midpoint theorem in the next video. Till then, take care, study hard, hit like if you like and subscribe for more. Thank you for watching.